had quite a bit of info to help you get the airfoil project done. What I did for you as part of the handouts that I gave you for the lab, you've got a line drawing. It's a 3-page line drawing and assembly view for the airfoil. This is the first page of it. It shows you what it looks like in 3-view. So you can see the top view, side view, and a front-facing view of the airfoil. So you're looking at one of the two skins in this section. You're looking at a cross-section of the rib here, and you're looking at the face of the spar. There's a total of 1, 2, 3, 4, 5, 6 pieces that make up the entire airfoil. You've got 3 ribs, 2 skins, and 1 spar that has to be bent. Some of the rivets are universal head rivets that are used in construction, and some of the rivets are countersunk rivets. The universal head rivets are going to be in one side of the skin, and this side, the piece of 032 skin. The countersunk rivets, the 426 rivets, are going to be in the 40,000 skin. And it reminds you of that in the illustration. So you have 40,000 skin that has to be countersunk. Let's take just some of the dimensions of this thing and just kind of take a look at what we have. The ribs measure 3.5 inches for the dimension at the leading edge, and the length along the center line of the ribs is 8.75 inches. I can't quite read that anymore. But they give you the dimensions for along the center line of the rib. There's a couple of lightning holes that are positioned in it. So you got a big one in the front, you got one that's to the rear of it. The rivet count is in the first page. There's going to be a total of 81 rivets that are countersunk rivets and 51 rivets that are universal head. The spar is also countersunk for a total of 9 countersunk rivets. And I think that's it. That's all the information that we can get from that first page. So if we take a look at the second page, it gives you more of a detailed view of the individual parts. The center line dimension is for the rib is 8.75 inches, so it's 8 3/4 inches. The spacing on the lightning holes is 2 inches from the 2 inches back from the leading edge, and the other one, the center of it is 3 inches back. The flanges on each of the ribs measures 3/4 of an inch, and that includes the front. And you're going to have a 20-degree cut in the flange of the rib in order to allow for bending and not cracking as you bend the material over. You'll have to also have a relief hole located at the intersection of the inside bend tangent lines. It'll be a number 30 drill hole. This is a profile view of the spar, what the spar looks like. If you look, you'll see it's not been quite bent to 90 degrees. I think the bend works out to be 81 degrees. So obviously the spar has got a taper so that it follows the skins, and then you can close out at the trailing edge. So this part, the part for the spar, has been bent 81 degrees. How can we check that at the break to make sure that we've got an accurate 81 degrees? Well, what I came up with something like this. This is a 81 degree bend on both of the flats over here. So you got 81 degrees on both of them. What I did is I cut a piece of sheet metal that's got a 90-degree angle. So if you take the 90-degree angle and line it up with that, its complement will be a total of 90 degrees. So if I do this on the tabletop, you can kind of see the way it works. See that? So with one flange actually bent in the break, what you can do is you can put the complementary angle that goes with it next to it, and it should fare up next to it. 81 degrees plus 9 sums to what? 90 degrees, right? Okay, so you can use that as a checking angle for doing the bends. Okay. So kind of a simplistic trick, but it works anyway for at least getting an accurate bend out of that thing. Anything else? You've got a total of how many rivets in each of the ribs along the length of the flange? You got a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rivets. You have to be careful also when you lay this thing out for measuring and marking for where the rivets go. Let me show you. On the leading edge, you can see that you've got a rivet here that really connects the spar with the skins. It has nothing to do with the rib rivets that are there. And the spacing that you have from here to here is not the same spacing as what you have from here to here. The spacing that you're using for spacing all the rivets for the rib is 0.875 inch spacing. So what we're gonna do is we're gonna measure and mark from the trailing edge of the rib going forward. We're gonna measure inboard what they call out as a 1/4 of an inch edge distance, and it's gonna be 875 spacing for all of the rivets that go along the flange of that rib. And then whatever this works out to be, I certainly guarantee it's not gonna be 875 spacing. It doesn't have anything to do with the attachment of the ribs to the skin. It has to do with the attachment of the spar to the skin. So again, just remember, it's not 875 measured this way going back, it's 875 this way for a total of 10 rivets in this dimension, okay? All right. So, common mistake. Sometimes I'll see projects after they've been completed, and they've got center punch marks every old which way in the thing, and I ask what happened, and they say, well, I measured from the leading edge, and I said, well, didn't I tell you in class that we were supposed to measure from the trailing edge going forward? Okay, well, it comes together then. The trailing edge of each of the skins has got to have a joggle in it that allows for a closure at the trailing end. So if you take a look at each of the skins that has got to be bent, you're going to have 2 bends in it. The material has to be put in the brake and bent one way. It's going to be taken out of the brake and then reinserted, reversed, and then bent the other way in order to give you 2 bends that form a joggle at the trailing edge. And I'll give you a hand with that. We can use a couple of test angles as well for bending. One of the test angles measures 24 degrees, and the other one measures 15. And it's actually the complement to the angles that you have here. So it'll work for you for doing that. I'll help you when the time comes for at least for bending the skins. The sad part about bending the skins is you destroy somewhat the first bend by bending the second. The dimension that we have on the brake for bending, or at least the leaf on it, it somewhat presses or compresses the first bend, but there's nothing that I can do about it. It's just the design of the brake. So we come as close as we can, but it should work fairly closely to get you a closeout that will match on both of the skins. So it'll work okay. So that's what we have for that. And let's take a look at the actual layout for the rib. This is what I would recommend doing in flat stock on your piece of 25 thousandths for making one of the ribs. You're gonna need a total of 3 of them. So what you might wanna do is you might do one on paper and then trace that one on paper on flat stock to make a total of 3. But to begin to make the rib, what I would do is I would make just one horizontal line that would kind of give you the developed width along the center line of where the rib is going to be. So what I did was, for the body of the rib, you're going to have a line that measures 8.6 inches. This represents the bend allowance for the leading edge flat that's going to be included, and then this is the unbent section for the flat at the leading edge. Okay. So I think if you sum all of these numbers, it works out to 9.413 inches. That's going to be the total developed width for the entire rib along the center line for that section of it. What I did then is I kind of erected a couple of parallels to that line, or perpendiculars, and one of the lines from end to end is going to measure 4.827 inches, and the center of it is located here. The other line measured from end to end is going to measure 2.077. As you might guess, that's the developed width dimensions for the leading edge and the trailing edge of the entire structure. And then what I did was I just kind of connected the dots in order to complete the rest of the puzzle to make it. So to do it, this represents the flat in the center of the rib. So I've split it both ways. So I've got 0.225 on one side of the center and 0.225 on the other. If you sum those two numbers, it gives you the unbent section for the middle of the rib at the trailing edge. Then on the outside of it, you're going to have what? What would come next? Bend allowance, right? So you're going to have to have bend allowance for the bend. It's a 90-degree bend for all of the flanges. So the bend allowance works out to 0.213 on each side of it. Okay? And then the unbent section that'll give you the trailing edge dimension when you're done of 3/4 of an inch kind of comes next. So that's 0.6 inches on both sides. So this kind of maps out what you need to do for at least the body of the rib. So again, this is the unbent section, trailing edge, the bend allowance for each of the bends, the amount of material required to make the bends, and then the unbent section for each of the flanges that are along the width of the thing. And I just kind of carried the lines forward in order to give you kind of the same thing here, that's tapered, okay? So, all right. So, okay, so far so good. Now we have to work with the leading edge. Well, you're gonna have 20-degree cuts that have to be included before you actually bend it. And so they're relief cuts. So what I did was I took a protractor and I measured back about 20 degrees this way. From the apex at this point, I also measured back 20 degrees, and I struck a line out from that apex. So this represents about 20 degrees on each side of the flat, okay? The flange at the front, again, that's gonna be 6/10 of an inch. And what I did was I just kind of connected the dots in order to give me the dimension for where the flat is gonna end at for the leading edge. Okay? So I end up with 3.2 inches here. And that dimension is really the inside bend tangent lines that goes from here to here. Kind of difficult to illustrate that in the view that I've got, but the unbent section at the leading edge is going to measure a total of 3.2 inches. And again, you've got a certain amount for bend allowance for the bend, and then you've got the unbent sections at this end. So this is at least how I kind of solve the problem in order to do the layout. Again, for accuracy, what I'd recommend doing is, rather than doing 3 separate ribs where you're gonna have a lot of error, I'd recommend doing one master rib on just a piece of paper and then tracing those dimensions onto your 25 thousandths thick stock. It'll work out, I think, a lot better for you. Where will the lines of sight go for bending this thing? Well, we're gonna be inserting the flanges in the brake. This is made with an 1/8 inch radius, so this would be the hidden bend tangent line. This would also be a hidden bend tangent line, and this would be a hidden bend tangent line. So measured and marked one radius inboard from that, that's where the line of sight is going to be located. So if we do something like this, that line measures 1/8 of an inch inboard from each of the inside bend tangent lines. Before you bend this also, what I'd like you to do is locate a couple of relief holes at the intersection of the inside bend tangent lines. It's not enough just to have a sweep back on the flanges to prevent it cracking. What I want you to do is use a number 30 drill in order to create a hole at these two locations. And so you're pretty much ready to bend. What I would also do, as long as, if I'm sure that everything is correctly positioned on here, you might want to measure where the lightning holes have to go. So the lightning holes are specified for their dimensions along the center line of the rib. You can measure 2 inches back and 3 inches back for their dimension. It's much easier to locate the holes when it's still flat than trying to figure out where they have to be after it's been bent. So, but this is again how I would do it. Question?
You're actually removing that material between the two 20-degree cuts, right?
Yes.
Okay.
Yeah, this is going to be cut back. You can use the 90-degree notcher that we have in the shop in order to do it. Oh, there's one other thing too. In order to get the rib to kind of stand on end so it's perfectly straight and if it were unsupported, add a little bit of additional material here, about 1/8 of an inch or so of extra material. So when it's been folded over, it doesn't have an angle at the trailing edge. And I worked it out by trig. It works out to be about 1/8 of an inch for that extra amount of dimension that extends from this point going out. So add about 1/8 inch of extra material, and it should be fine. And allow it to finish off, or at least join with a line that represents the inside bend tangent line at this point. Do that for both of the sides, okay? And should work out okay for you. Shouldn't be too difficult to do. Okay, so this is going to be in 25 thousandths material. The relief cuts are 20 degrees. You're using an 1/8 inch radius for bending. So I've done all of the bull work for you. It's not drawn to scale, but it's pretty good. So it'll give you all the dimensions that you need. Another helpful piece of advice that I have after teaching this class for 3 decades, and I'll tell you what it is: do the layout at home. It's kind of noisy in the shop, and people are going to be using rivet guns and drills, and the last thing that you want to have happening to lose concentration is to listen to that noise. So what I would recommend doing is squaring all your material at home, and over the weekend, some weekend, spread it out over a tabletop and do all of the layouts there. So it'll save you an enormous time rather than try to do it in the lab. You're wasting tremendous amounts of shop time just trying to do the layouts in the lab when you could do the layout just as easily at home, or actually better at home. Okay, so that's my advice, take it for what it's worth. So you're gonna need 3 of them anyway to complete the rib. You might wanna also consider making a spare rib in the event that you screw up one of the ribs in bending, or maybe you can use one of the ribs as a trial rib to see that it all works when you bend it. And but you might want to produce a total of 4 ribs, just one as a trial rib for bending, and it might work okay. All right. Any questions on doing the rib? Yeah.
For the relief hole, do I drill as close to that edge as I can?
You're going to be, before the metal has been even cut, all you have to do is, yeah, you're going to position the hole right there.
Okay.
So in flat stock, without cutting any of this away, you're first going to drill that hole.
Got it.
Okay. 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 So far, so good? All right. Okay, next. Let's talk about the spar. For the layout of the spar, it's a lot easier to do. You don't really have intersecting bends to worry about, but I've given you all the dimensions that you need for doing it. The spar is made out of 40 thousandths thick 2024 T3, and the unbent sections are 609 each and 3218 for the base, and the bend allowance is 202. You're going to be inserting the flanges in the brake for bending. So this represents the hidden bend tangent line for bending. This line also is the hidden bend tangent line. You're using an 1/8 inch radius bar for bending, so measure and mark inboard from that. This is where the line of sight is going to be. And again, what I would do for checking each of the bends after you've bent them, with the parts still in the brake, what you'd want to do is you'd want to use the test angle of 9 degrees to see that in fact it fares with it. So this has been bent 81 degrees for each of the flanges. Okay, makes sense? All right. Okay. So far so good. No relief holes to drill on this thing. The important thing is to know when to quit. So again, don't bend the thing to 90 degrees and then try to straighten it back out. It's going to be very difficult to unbend it. So try to bend it. You're going to certainly have to allow for a little bit of spring back, but you want the final bend to rest at 81 degrees for each of the bends. The skins. One skin is going to be made out of 40 thousandths thick material, and the overall developed width is 11.507. And these lines represent the bent tangent lines and the unbent sections that you have in it. It was kind of difficult to illustrate it, it was kind of small to actually measure and mark it, so I kind of labeled it up here. But one of the bend allowances works out to 509. The other bend allowance is 037. So, the lines are going to be fairly close together. This is kind of the interesting thing too. The radius that you're bending on is actually larger than the amount of bend allowance. So look where the lines of sight have actually been positioned. So you're using an 1/8 inch radius bar, and your amount of bend allowance is only, in this case, 037. It displaces the line of sight beyond the other bend tangent line. A lot of times when you bend, you'll see that the line of sight will be somewhere between the 2 bend tangent lines. But again, because the bend allowance is rather small, it forces the line of sight to be pushed out, okay, fairly far. So that's where they're going to be located. You're going to have lines of sight on, at least one of the lines of sight is going to have to be located on the opposite side of the sheet. Because again, you're going to be making one bend, taking out of the brake, turning it upside down, and then making the second bend. So you're going to have at least one of the lines of sight positioned on the opposite side of the material. Okay. So this is the 40,000 skin that you have to bend. 15 bend first, invert, and then make the 24-degree bend. So again, I'll give you a hand when it comes time to do this. Okay. The 32 skin, it's almost identical. The bends are the same, however the skin thickness is different. So you end up with almost similar dimensions. It's even difficult to discern when I look at them. I use the same checking tool to verify you've got the same dimension. It's fairly close. Again, we're going to be making the 15-degree bend first, and then the 24-degree bend later. And you're going to have to invert it in order to make the second bend. And that's how it is, okay? Now, here's what I would do. And everybody's a little bit different, but you'll notice Other than drilling that relief hole before I bent, there are no other holes that are in that thing. You don't want to measure and mark where the rivet locations are going to go until you can rest assured that all of the parts kind of fit together kind of correctly. Now, you're going to notice also that one rib may fit a little bit better in one position than in another position. This is where it kind of pays to do a trial fit, maybe kind of taping the thing together with some painter's tape to see how it kind of fits together, because there's going to be some slight inaccuracy in bending. But you want to have the thing look the best it can be. So what I would recommend doing is, without drilling any holes in the thing, what I would do is I would kind of tape the thing together and see how it kind of looks. And then just the position of ribs as required in order to get the structure to be as straight as possible without any waviness in it. And that's what it should kind of look like. Once you get the thing kind of indexed the way that you want it, you can measure and mark where all the rivets are going to go. Notice I didn't say center punch. What I would do is I would measure and kind of figure out where all the rivets have to go. And I would certainly mark which side of the skin faces out. So a lot of times when people are drilling and they go to reassemble the thing, they realize that they've drilled the thing and they drilled it on the opposite side, and then when it comes to they can't match drill it with the part that's beneath it. So again, what I want you to do is just use a Sharpie marker and mark where all the rivet locations are going to go. When you're satisfied with that, then you can center punch, okay? But if you make a mistake and you just go center punch crazy, you're probably going to end up with marks where there are no holes that really have to be. So it's going to look kind of funny. So that would be my advice. For assembly of something like this, well, you can't really paint yourself into a circle or into a corner. I would not do this in assembly. What you're going to have to do is you're going to have to attach 2 of the ribs to the spar, put one of the skins on top, and then reach onto the inside in order to get the flange of the third rib that is going to be protruding. So what I would do is I would put these 2 ribs on maybe first, attach it to the spar, put the skin on top of it, then insert the rib, and then I would be able to get to the to that flange of the ribs in order to be able to finish it off. And then, with the other skin still installed on the other side, you can reach in and do it. I've got a long bucking bar that will help you in this operation. But again, you're not going to be able to put all the ribs on the spar and be able to get in to finish off one of the sides of the ribs with a long bucking bar. There's no way to get through to do it. So again, you're going to have to think on how you want to assemble it. But in any event, it would kind of look like that, but not exactly. This shows one of the skins installed. But again, what I would do is I would assemble what I could, this rib, this spar, and the skin to maybe 2 of the ribs, then reach in with the other skin in place, and then I would finish off this particular rib on that side. Then I would close it out by putting this rib in and finishing it off, installing it in that position. Do y'all see what I'm kind of saying? Mm-hmm. All right. So that's kind of what I would do. So again, very easy to make mistakes, but if you're careful, you won't make too many of them, but I've seen them all. Common mistakes, again, the measuring and marking for where the rivets have to go. This rivet that's in the leading edge by the spar, it doesn't have anything to do with the ribs. So the common mistake that people will do is they'll measure 875 back from the leading edge. That's incorrect. What I want you to do for measuring and marking is measuring 1/4 of an inch inboard from the rib and then measuring 10 spaces for the rivets that way. And then whatever this works out to be is whatever it is, okay? So it's a little misleading on the print. Don't measure from the leading edge working out. Another common mistake, people forget to take the plastic off when they assemble the parts. How many times have I reached on the inside and I feel, oh man, what am I feeling, Well, the plastic, you forgot to take it off of the material. All of the parts should be as perfect as they could be. They have to be deburred and the plastic has got to be removed. What I would recommend also is kind of guard the bucking bar. If you have to wrap a rag around it or you have to put some tape on it around the sides of it to prevent contacting the material, do so. The working surface of the bucking bar should be polished steel. They shouldn't have any type of cover on that. but you want to avoid marring the clad skin as much as possible. So again, wrapping a rag around it is okay to do. Also too, when it comes time to use that long bucking bar to rivet, when you have to get the mid-rib riveted in, what I would recommend doing is finding a partner that you trust in the lab to help you buck the rivets. One person can shoot and the other person can buck. So pick a person that you kind of trust that's not going to be slipping off of the shank of the rivet as you're bucking, and things should go okay, all right? So, okay. That's it. Okay. Helpful things to remember. This is really important. When you don't go to do the layout, if you're sloppy with a Sharpie marker and you've got coarse, thick lines, your layout is going to be extremely inaccurately bent. So you're going to have to use a very light pressure with a Sharpie marker, use an ultra-fine, fine line Sharpie, and very extremely knife edge lines with that Sharpie marker for all the marking. Also remember too, it's easy to make a mistake and confuse a bent tangent line with a line of sight. Use different colors for marking purposes, maybe one color for line of sight and another color for the bent tangent lines. Or certainly use a dotted line to indicate where the line of sight is to make it different than the rest of the lines that are on it. Okay. Bend all parts and trial fit before assembly. As I told you, what I'd recommend is kind of taping it up and finding how it kind of sits together kind of correctly best, and then working from there. And after that's done, then you can measure and mark where the holes have to go. Obviously, all the parts have got to be deburred on all the edges and have to be deburred at that point. So you're not going to be individually drilling any holes either. When everything looks correct, then you can mark and then you can drill. But again, don't drill one hole and try to match it with undrilled material. So all the parts have to be lapped together in any drilling. Okay. Preventable errors. Mismarked, inaccurate, developed with measurements. And again, if you get sloppy in your measurements, well, it'll translate into your work. You just have to be very careful when you do it. Incorrect rivet layout, rib to skin attachment in particular at the leading edge. Installing rivets with a protective plastic between them on the manufacturer's head. So again, sometimes you leave the plastic in place and people are trying to pick the plastic off after they've riveted. It's impossible to do that. I hate that for another reason as well. The rivet doesn't seat itself on the material, and also leads for the potential for corrosion to start because of the gap that you have underneath the head of the rivet. So again, that's kind of important to do. When you're doing the countersinking for the 40,000 skin, what I would prefer that you do is, after you got all the holes located, on a piece of wood, I'd recommend that you use that as a backing strip and then countersink all of the holes. So rather than putting it directly on the structure and using that for support, you'll get better support if you use a piece of wood to use it as backing rather than the structure itself. If you set up the countersink tool on scrap material for the depth of cut one time, it'll be perfect for all of the rivets. But you're going to have to do your job as well too. If you're allowing the cage of the countersink cutter to kind of swarm all over the place, you'll find out that it's going to leave out a dish countersunk depression. So it starts with a good hole to begin with, and then after that, good countersinking technique and finishing it off. So again, the onus is kind of on you. You have to do kind of good work for that. So any questions on doing the skins, anything that you need to know? Or doing the piece parts? Here's one. This one, strangely, somebody left this in the lab. I would not have left my project behind. This one is actually pretty good. Does it have mistakes in it? Yes, but they're not fatal mistakes. You'll notice that there's lack of bucking bar strikes in the thing, so they were careful when they put it together. The countersinking is pretty darn good. They're flush all the way around. The universal head rivets don't have too many, or the skins don't have too many flaws in them. A couple of places they were off when they were riveting. It's very difficult to get that mid-rib perfectly riveted because they're kind of sliding around with a bucking bar and trying to manipulate the rivet gun at the same time. So there's a few little mistakes that are on that part of it. But the parts are very well bent. The parts have all been deburred. If I look on inside through the lightning hole, I can see the mid-rib, and I can look at both of the flanges, and they haven't damaged that at all. So this one actually worked out pretty good. Your project is gonna be marked in the trailing edge with the last 4 digits of your student number. So when you get the thing done, bring it to me and I'll mark it. I would anticipate that finishing this project off is going to take probably about, I wanna say about 6 lab periods in order to get the thing done. So we've got 8 lab periods left. So if you wanna work at a reasonable pace and finish by the end of the semester, I would allot maybe 6 total periods to get the thing done. But again, remember what I told you, you can help yourself. Do your layouts where?
Home.
That's right, okay? So, just my advice, all right? Okay. By the way, too, I wanna check your layouts. What I'll look at in flat view, I wanna look at all of your developed width for all of your parts. And let me give you the due date for that thing. There's a due date for it. And let's look at the syllabus for the lab. You've only got 1 written assignment for each of the classes that I teach, but for the lab, what I want you to do by April 19th, what I want you to do is I want you to lay out all of the parts, not just 1 rib. I want you to have all 3 ribs laid out on a piece of metal. I want to see the spar, and I want to see both skins laid out with a Sharpie marker. You don't have to indicate where the rivets go, nothing like that, but I want to see where the developed width is, what the lines of sight and the bend tangent lines. And it's due on the 14th of April. You've got spring break to kind of work on this. What I would do is another piece of advice. You've got spring break coming up. Square the material that you need to get this project done and work on it over spring break. You've got at least a week in order to kind of get the thing laid out. So again, use the time to your advantage. You know, it's amazing how quickly the time just kind of flies by in the lab. So again, just some advice that I have. So that's that.